Okay, now children, let us see why the topic is trigonometric functions. Let us try to relate it to the previous chapter we have done, that is functions. Okay, suppose we have an equation y is equal to sine x, where x is denoting the angle subtended at the center. Okay, so if you see, x is an independent variable here, and for each value of x which is denoting an angle, there will be a certain value of y. Let us take an example. Say if x is 30 degrees, then we know that sine 30 degree will be equal to 1 by 2. So when x is taking the value 30 degree, corresponding to it y is taking the value 1 by 2. In the same way, if I replace x by say 45 degree, then y will be sine 45 degree, which is 1 by root 2. So 45 degree is getting related to 1 by root 2. In the same way, 30 degree is getting related to 1 by 2. You replace x by 60 degrees, then sine 60 degrees will be root 3 by 2. So 60 degree is getting related to root 3 by 2. So you can see every value which x is taking, corresponding to it, we are getting a unique value for y. So that is why it is a function. That is why the name trigonometric functions. Now let us see the values of various trigonometric functions at different angles, what they will be. First, let us see their values corresponding to angle 0, pi by 2, pi, 3 pi by 2 or 2 pi. Okay. When each one of the right angle is completed at that particular point, what will be the value of trigonometric ratios? For that, I am considering a unit circle. Unit circle means a circle with radius only 1 unit. So we have taken a circle with radius 1 unit and O is its center. So OA, OP, OC, OD, they all are denoting the radii, which is equal to 1 unit. Now in the first quadrant, in this arc, I have taken a point P such that this arc AP is making an angle of x radian at the center of this circle. So angle AOP, not AOB, this is AOP, this is equal to x radians. That is what we have taken. Now we have done a result earlier that theta radian is equal to arc length over radius. So over here in place of theta, the angle taken is x radians. Arc length we are yet to find, which is AP, and radius is 1. So what do we see? L is equal to x. So this arc length AP will be of x units. Now keeping this in mind, let us evaluate few of the trigonometric ratios. Now look at this triangle OMP. It is a right angle triangle. If we define cosine of x, okay, cosine of x will be the base divided length of the base divided by the length of the hypotenuse. So base over here is denoting OM is denoting the base, OP is denoting the hypotenuse, and P is assumed to have coordinates a comma b. So if I say P has got coordinates a comma b, that means its x coordinate is a and its y coordinate is b. So what is the length of OM? It is a unit. OP is 1 because it is the radius. So cos x is coming out to be a. In the same way, if we calculate sin x for it, it will be the altitude divided by the length of hypotenuse. Now altitude is b unit, hypotenuse is 1 unit. So sin x is coming b. Also, because it is a right angle triangle, it will satisfy the Pythagoras theorem. That means we get a square plus b square is equal to square of 1, which is 1 only. Now again, using this, a is equal to cos x, a square can be written as cos square x, and b is equal to sin x. So b square can be written as sin square x. So we are getting the identity cos square x plus sin square x is equal to 1. So what do we understand from here? No matter whatever is the measure of this angle, okay, you can stretch it to second quadrant, third quadrant, fourth quadrant, you can complete the revolution, whatever is the measure of this angle. So for this unit circle, maybe if the point P is here, here or here, wherever, depending upon the measure of angle, every time cos square x plus sin square x will be equal to 1. Okay. Now let us use it to get the values of various trigonometric functions at different values of x. Now see, if I talk about this angle AOB, then this angle is a right angle. So its measure is pi by 2. What about this angle AOC? It is a straight angle, 180 degree. 180 degrees, pi radians. In the same way, when I say angle AOD, keep in mind in the first session we discussed what is the way of evaluating the angle. It will be always anti-clockwise. So when I say angle AOD, we are talking about this reflex angle. Okay. So this way. So it comes out to be 270 degree. Means 90 degree how many times? 3 times. 1 time, 2 time, 3 time. So it comes out to be 270 degree. In terms of radians, it is 3 pi by 2. Okay. And if I complete the revolution, AOA, if we complete it, then the angle will be 360 degree. That means 2 pi. Okay. So now look at these particular points. What are the coordinates? Coordinates of A are 1, 0. That of B is 0, 1. C has got coordinate -1, 0. D has got coordinate 0, -1. This is going to help us in defining sine and cos at different angles, like at 0 degree, 90 degree, 180 degree, 270 degree and 360 degree. Now listen to this part carefully. Suppose this point P coincides with A. At that moment, this angle X will become 0 degree. Okay. So if X becomes 0 degree, that means P and A are coinciding with each other. Fine. And we know that cos X is how much? A unit. If I replace this X by 0, then cos 0 will be A unit. Now when P is over A, what will be the length of A? See, if P coincides with capital A, then this small a will be equal to 1 unit. So when cos 0 degree you are finding, it will be equal to A, small a, which is the x coordinate of P. And you can see if P is over A, then small a is equal to 1 and small b is equal to 0. So you keep that in mind and then try to find these. So when P is coinciding with A, x is equal to 0 degrees. So cos 0 degree is 1 and sine 0 degree comes out to be 0. They are the values of A and B at the point A. Okay, now move on to 90 degree. If P is coinciding with B, then this angle AOB, or you can call it AOP, it will become 90 degree. So when P coincides with B, the angle X becomes 90 degree and small a will become equal to 0, small b will become equal to 1. So cos 90 degree will be A, and what is A equal to? It is equal to 0. So cos 90 pi by 2 is becoming 0. In the same way, sin 90 is equal to B, and what is B equal to? B will be equal to 1. So sin pi by 2 is 1. Now these values you are already aware of, you have done in class 10th. But same thing you need to follow in order to get cos 180, sin 180. See, when this point P will coincide with the point C, they will become coincident point, then this angle X will become 180 degree. So in that case, A becomes -1 and B will become 0. So keeping that in mind, see, cos 180 degree is A, and what is A? It is -1. Look at this. Then sin 180 is B, and what is B at this point? It is 0. So sin 180 is 0. In the same way, we can check for cos 3 pi by 2 and cos pi. When P coincides over D, the angle X will be 3 pi by 2 and small a will be equal to 0, small b will be equal to -1. Okay, so cos 3 pi by 2 will be small a, and see here small a is becoming 0 and sin 3 pi by 2 will be B, and B is -1. So you need to understand. See, here sin 90 is 1 and this is negative of the y-axis. You can see D is the image of B. Okay, so sin 90 is 1 but sin 270 is -1, negative of that. In the same way, see, cos 0 is 1 but cos 180 is -1. This is how also you can remember. Then coming to sin 2 pi, angle 2 pi. So if P comes here and coincides with A. Okay, so the angle AOA, that means whole revolution you have taken. it becomes 2 pi. And in that case, AB will again coincide with capital A. So small a will become 1 and B will become 0. So you can see cos 2 pi is again 1, same as cos 0 degree. Sin 2 pi is 0, same as sin 0 degree. Because whether we are talking about the angle 0 or 360 degree, they are coincident angle. Okay. So these are the values of two trigonometric ratios I have discussed at various points. In the same way, you can define for tan theta. See, this will imply tan 0 is how much? It is sine over cos, which is 0 only. This implies tan pi by 2 is not defined. Fine, because it is taking the form 1 over 0. Then tan pi is 0 over minus 1, which is 0 only. Then tan 3 pi by 2. Tan 3 pi by 2 will be minus 1 over 0. So again not defined. Okay. And tan 2 pi is 0 over 1, which is 0. Okay. Using them you can define the remaining three trigonometric ratios also. Now see some of trigonometric functions, how signs of trigonometric functions, how they vary in different quadrants. I have extended the same figure. What we have done, we have taken image of point P as Q. Okay, if we take its mirror image, then the coordinates of Q will be A comma minus B. This is the fourth quadrant, you can see. So the x coordinate remains positive, but the y coordinate becomes negative. And this is again a right angle triangle. OQ is a radius, so it will be of 1 unit only. Now I am comparing both the right triangles one by one. But see, over here the angle is measured in the anti-clockwise direction. So its magnitude will be same as x, but its direction is different. That is why this angle is minus x. Okay, see the behavior of the trigonometric functions in these two triangles. In the upper triangle, which is in the first quadrant, you can see in triangle OMP, we have proved cos x is A. But in the triangle OMQ, we will not write cos x, it is cos of minus x, because the angle over there is minus x. So this right angle triangle, if you take, cos of minus x will be OM over OQ. Now OM is again of A units, OQ is 1. So cos minus x is also coming A. Cos x was also A. So what do we come to know from here? Cos of minus x is cos x only. Okay, let us check for sin x. In the triangle OMP, sin x we have proved it is B in the previous part. When we take this triangle in the fourth quadrant, sin minus x will be the altitude, which is MQ, divided by OQ, which is the hypotenuse. Now MQ will be minus B. See, it is in the fourth quadrant. So minus B over 1. Okay, it is in the fourth quadrant. So what are we getting? Sin minus x is minus B, where this B is equal to sin x. So what we come to know? If it is sine of a negative angle, we can write it as minus sin x. But if it is cos of a negative angle, it will be cos x only. Quickly checking for tan x. See, in the triangle OMP, tan x will be B over A, the ratio of altitude and base. And in triangle OMQ, tan of minus x will be minus B over A. Again the same reason, MQ over OM. So MQ will be minus B over OM, which is equal to A. So we see B over A is tan x. So tan minus x is reducing to minus tan x. Now in the same way, we can conclude the result for their reciprocals. Cot of minus x will be minus cot x. Cosec minus x will be minus cosec x. Sec minus x will be sec x.